Right. So density is a combination of the mass and the volume of an object. Another way of looking at it is if we have a 1 cubic meter. So imagine we have basically 1 cubic meter. I'll draw it, well, do 1 square meter because it's on paper, it's easier to draw. If I have that number of particles in, of say, let's say that one was wood, for the same size 1 square meter of iron, I would have more particles. So the particles I can get into 1 cubic meter of iron are greater than the number of particles I can get in for wood. So wood is not as tightly packed or densely packed, we might say, as the iron. And that's basically what density is. The amount of molecules, the amount of the material that you can get into the same area. So iron, you can fit more molecules of iron in the same space than you could if it was a piece of wood. So this is what density is, how tightly packed the material is. So dense material isn't necessarily a heavy material, it's a material where the molecules are very tightly packed together. So density is a mixture of two quantities, the mass and the volume. Okay, so the bit you need to underline is density is mass divided by volume. In symbols, that's D equals M divided by V. D is density, M is mass, V is volume. Okay, you need to know and learn that equation. So highlight or underline that equation. That is an equation you need to learn. So in a test, an exam, that equation will not be given to you. You'll be expected to know that equation. Okay, so density is the mass of something divided by the volume. And the definition then is, if you underline, the density of a substance is the mass of 1 cubic centimeter of the material. So effectively, what density is the mass of 1 cubic centimeter of a material. So a cubic centimeter being a height of 1 centimeter, a width of 1 centimeter, and a breadth of 1 centimeter as well. So 1 centimeter by 1 centimeter by 1 centimeter cube of material. So it's the mass of a 1 centimeter cube of material. So 1 cubic centimeter of iron would have a greater mass than 1 cubic centimeter of wood. Okay, so it's how compressed it is. Another way of thinking about it is think of a balloon, a helium balloon. Before a helium balloon is blown up, it would sit on a desk. Okay, if you picked it up and let go, it would fall down. Okay, but if we can make its volume bigger, so if you fill that balloon with helium, the volume, the balloon is now much bigger in size. So what does it do? It floats upwards. The actual balloon material itself is exactly the same mass, but make the volume it takes up by adding helium to it, it will get a bigger volume and therefore a smaller density because the material is now more spread out, just like our ship. The iron can float because the iron, which if we compressed it all down, remember this is the outline of the ship, that's the actual iron. Most of the ship is empty space. If we squashed all that iron down or steel down, it might make up this volume. So that is the actual volume of the iron, but this is the volume of the ship. So the ship has got a very big volume compared to its mass, whereas the iron, if the steel is crushed down, will be down, this is the volume it will take up, and that would sink. This floats because the volume of the steel is made much bigger. So when density is equal to mass divided by volume, volume is big enough, it will decrease the density. Now, the density of water is 1 kilogram per cubic meter, or sometimes, since a kilogram and cubic meters are quite big units, sometimes we measure density in grams per centimeter cubed. Okay, so the density is measured in grams per centimeter cubed. If we could underline or highlight that bit. but the actual unit of density, because the unit of mass is the kilogram, so density is measured in kilograms per meter cubed. Because a meter cubed and a kilogram are big units, more commonly we'll use grams per centimeter cubed. Now, all this is then, if you follow through the instructions, is an example of how to measure the density of an object. Now, you can do this yourselves at home. If you happen to have, if you don't have this, doesn't matter, I'll put the link again in of how we've done this. You just need some stuff you might have in your kitchen. So a measuring jug, okay, if you do any baking, bit of a bake-off, okay, I've got a measuring jug here, and this measuring jug has 250 milliliters of water in it. Okay, I'm going to measure the density of an apple. How do we do that? Okay, the instructions are all on there, instructions 1 to 7. To follow this through, you can do this yourself at home. I've pre-written in these, I've done this already. Okay, my apple, okay, I'm going to measure the density of an apple. I'm going to measure the mass of the apple. Measure the mass first using a common kitchen scales. Okay, so you can see the output of that one hopefully there if I zero it. Not quite, there you go. Okay, so if you have a kitchen scales, which you might use for measuring flour or sugar or whatever at home, you can use that. If you don't have this, don't worry about it. So I'm measuring the mass of my apple when it stops wobbling around. And that mass of apple is, you can see there, hold on, the light's not great. I'll get that before you can see there, that is 147, if I can get the light to actually work. Hold on, let me just light that up. There you go. So that has got a mass of 147 grams. So in column 2 on my book, I write down 147 grams. The volume of my apple, you can get this. So I've got 250 milliliters of water in my measuring cylinder. So in column 3, volume of water without the object is 250. Place my object in, which is the apple, and you'll notice the apple floats. So you need to get that apple fully underwater, so use a pen to push it right down so it's fully underwater. Okay, and now my volume is 400 milliliters. Okay, approximately. Don't worry about doing it 100% accurately. Those results then into my book. I've got my volume of water 250, my volume of the water with the apple in is 400. Column 5 is column 4 minus column 3. 400 minus 250, that means my apple had a volume of 150 milliliters. Density is mass divided by volume. The mass is column 2 divided by the value in column 5, which is the volume, 147 divided by 150 gives me 0.98. So the density of an apple is 0.98. So that's less than 1, and that floats. Anything with a density of less than 1, less than the density of water, floats. I also measured a marmalade pot, which I put in, okay, and these were the values I got there. So that had a density of 1.6. which basically meant my marmalade sinks, okay, as you can see there. So something that is denser than water will sink, okay? So in summary, I'm just going to end my recording there.